Today, let's go over a medium that I just solved by myself. This one is called range sum query 2D immutable. And I found a way to get over time limit exceeded, which is a neat trick I'll show you. So you're given a 2D matrix and you basically look at the picture. You want to get the sum of everything in this matrix in this particular region. And obviously the easy way to do this is to iterate through every single cell in the matrix and add them up, right? But that's going to get time limit exceeded. Range column 1 to column 2 plus 1. And then let's declare a result. Result plus equal to row 1 of result plus equal to self dot mij, right? And then just return the result. That'll work for like half or more of the test cases, but that's just brute force, right? O of n squared. They want you to do it on O of 1. So the way to do it, I'll show you, okay, is we don't have to actually build a prefix grid. If you know how a row works, for example, the first row is 3, 0, 1, 4, 2 that they give you. So why don't we just accumulate this? So 3, the sum up to this point is 3. The sum up to this point is 4. The sum up to this point is 8. The sum up to this point is 10. Everything. So, and then when we want to find the column, we just chop off the point we need. For example, if we want the sum of this, then as you know before, it's just this minus 1 to get this. So to get the region of this, so would be, so 3, 0, let me make sure I'm doing this correctly, is 4, 8, 10. Yep. So if we want to get the sum of, this is the prefix, if we want to get the sum of this, it's just 4 minus 3, which is 1. If we want to get the sum of this, it would just be 10 minus 3, which is going to be 7, I think. So this is 5, right? So for 5, oh, sorry, for 5, yeah, it's 8 minus 3. It's the current one minus the previous one minus 1. And if it's this one, previous one, the low index is 0, then just the whole thing up to that point, right? Just like we said yesterday. And so let's build that right now. So let's call this self.new. And then for each matrix, let's just append a list. Python has a nice accumulate function to do that, create this basically. So let's print self.new to see. Just put a dummy value in there for now. Okay, cool. So we have 3, 3, 4, 10, 8, adding everything up to a current point in each row. And then now some people just call it directly, like there's a nice trick, but I don't think that's intuitive. I think the way to do it is we still want to iterate over the row to row 2 plus 1, so we can still iterate over the rows. So 1, 2 rows instead of having to rotate over every row and cell. That's O of n squared. This is just O of n. That's acceptable here. So here, as we mentioned before, let's define result. Let's just say if, let's say the low column is equal to column 1, because that's defining the left boundary, and then the right column is column 2. It's defining the right boundary. So like this. And then, so if low column is less than or equal to 0, then result just plus equal to whatever. If it's 0, then everything up to that point to right counts, right? So result plus equal to self.new of I, which is the current row, because I is between row 1 and row 2 plus 1 inclusive, because Python goes up to not including this value. And now we can just say right column. For example, if we want everything up to, the sum of everything up to this point is just 8, right? So row 2 would be 0, 1, 2, 3. In that case, when it's bigger than 0, the left boundary, then you can just subtract this number by this number to get the sum of this. So result plus equals self.new. I, still defining the current row first. And then right column minus self.new I. The row again, right or left column minus 1. So that's just going to give you the prefix sum of the row. Iterating over all rows, we can just return results. Left column minus 1. Left column. Why are we calling this low column? And there you go. It actually works. So it's not the most efficient, but it at least doesn't get time limit exceeded. I'm sure there's a better way to do this. If you watch Leetcode, he has a better way, but this is way more intuitive to me. And so that's what I'm here to show you. And I'm glad that I solved it. So thank you for watching and stay tuned for more.